All right, today we're looking at something called the mid-segment property. Um, we'll work with triangles. We'll also work with trapezoids today in mid-segments. So hopefully this will make a little bit of sense. Couple of things to look at. We are using 3 and 1s today, so hopefully that'll work nicely. Another thing, there are two proofs. We will review tomorrow, and then we will actually take our test on Wednesday. So that'll be over all these triangle components, the trapezoids, the kites, the summing together, things that we've talked about the past couple of days. We'll work on that. That'll be a test on Wednesday. I hope you guys are getting ready for that. We've kind of reviewed a little bit throughout the week, and there's good stuff. So hopefully with your 3 and 1, you're pretty good here. It says mark the midpoint of FR as A. So I don't know, maybe it'd be somewhere like around here. A. Midpoint means the middle. Yep, exactly halfway between F and R would be A. The midpoint of F and I would be B. Also, that's going to be over here. It says B. Okay, it then says draw mid-segment AB. So that looks like this. This is actually called a mid-segment. Why do you think it's called a mid-segment? Yeah.
Line, it's a line segment in the middle.
Yeah, it's a line segment that's kind of about halfway between here and this part right here, correct? And it's the midpoints here, and so it's kind of like halfway between there, right? Okay. What's the length of AB in centimeters? What did you guys find?
15.
You found it in centimeters. It's 15 centimeters.
I did
You had 4?
Oh, never mind. I took it.
Exactly 4?
3 and a half.
I got 3.5.
What did you guys get for RI?
7.5.
Okay, so that's kind of the weird part. These need to be exact, so maybe we got to figure out how to measure these. You're going to use this centimeters part of it, which on here it's labeled as millimeters because that's what the small pieces are. And I think it just assumed that you guys would know that if you're working with centimeters and then they're just 10 millimeters. So the big numbers, 1 through 11, those are each centimeters. So if you were to measure RI, the longer one, you should get right around 7.5 for RI. 7 point, maybe 6, maybe 7.6 centimeters. You're going to know the principle for it, so it'll be different then. So then when we measure this part, when I measure this, I got this to be 3.8, just a little bit more than 3 3/4 of it, so 3.8 is what the length of AB would then be. Okay, so if you had something different, just adjust it right now, not a huge deal, just adjust it. So this length right here is 3.8 centimeters. This would be 7.6 centimeters. Now there's two properties that exist here, okay? One thing you can't necessarily tell from this picture, but this is going to be parallel to this. Okay, so maybe write those markings on there. Parallel is just an arrow on each one of those lines. Means that those lines are going to be parallel. And secondly, how are 3.8 and 7.6, how are those related? One's half the other one, right? Okay, so in this conjecture here, it says the mid-segment of a triangle, the mid-segment, right, the segment that's halfway between the vertex and the base, is parallel to the third side, or we can call this the base, however you want to talk about that. And is, and we should say is in half the length of the third side, or we can call this the base. Okay? So those are two properties that exist with mid-segments. Hopefully you've written both of those down. The idea here, again, if we look at this, if we know these are mid-segments, it says MP is a mid-segment of each of these triangles, find the value of x. Again, what that means is that this side, those two pieces are congruent. It means these two pieces are congruent. It means this is parallel to this. And it also means that x is half of 16. So what's x equal? 8, okay? Now here's the deal. That's really easy. Just look at it and be like, okay, it's half of this, you're done. Okay? But if they were to ask, if they said this is 4, they could say, how long is MN? Or MN, just MN. That would also be 4. They could say, how long is LN? Well, it's 8. Okay? What if they said this is not drawing the scale at all? What if they said LP is 16? So how long is OP? 16. The whole thing here is 32, and we can kind of figure this thing out. There's several things that it could ask for. It could also say, hey, what if this angle right here is 27 degrees? How big is this angle right here? It's also 27 degrees. How do you know that? They're corresponding angles, okay? If these two lines are parallel, they're also going to be corresponding angles. It's kind of things that we've talked about earlier in the semester that are going to kind of keep coming up. So we may have to review those just a little tiny bit so that everyone's on the same page. Okay, number 2. It does say it's the mid segment, so we know, again, that this part is congruent to this part, this is congruent to this piece. We know these are parallel to one another. We also know that 7 is going to be half of x, so how big is x? 14. Okay. Those are pretty easy questions, very, pretty elementary things. So look at it and be like, well, if it's 7, then that's got to be 14. Okay? There will be some more complicated things. What if they said this was like, 2x minus 17? Did we figure that out then? Yeah, we just say, hey, 2 times 7 has to be equal to 2x minus 17. Figure this problem out, if that was the case. Just that twice this thing up here has to be equal to that spot. Okay? Obviously, whatever I just made up doesn't really probably make sense, but hopefully it works. Okay? Investigation number 2. Use your ruler again. You're 3 and 1. Maybe you already started this. Mark the midpoint of VA. Mark the midpoint of VY, and then AY. And then draw 3 mid-segments. We're going to take a look at this and see what this means for us. Okay, so just take maybe a minute, get those things going, just draw all those pieces in there, and we should be okay. Hopefully yours are going to be a lot more accurate than mine here. Yes, sir.
You don't celebrate Halloween. You don't pass out candy here.
I don't really eat candy. Okay. So here's the thing, like if people were to come to my house, I think they're just going to keep coming back if you keep giving them stuff, especially if they give them stuff they want. So actually, we're having a Bible study at my house tonight, and our light will not be on. Kind of just how it works. This is what we do on Mondays, every Monday, whether it's a pagan holiday or whether it's another thing, whatever else. Actually, I think I live in your neighborhood, so that's sweet. All right, here we go. Hopefully, you've drawn all this up here. And we have some things going on. I want to show this to you. This is this line is going to be parallel to this line right here. This line right here, this is kind of weird. This is going to be parallel to this guy out here, so that's kind of strange looking. And I guess we'll use 3 here. This is going to be parallel to this line over here. Okay. And here's kind of the weird part. This might take a little bit of drawing to figure out, but this part right here, see how it's half? We have this line right here, those 2 guys, and they're each, we'll just say that length, okay? So I just make up a length for you guys. Let's say this is 5, this is 5. How long is this piece right here going to be? 5. It's also going to be 5, because it has to be half the length of this whole thing. So 5 plus 5 is 10, it has to be half of that, so that's going to also be 5. Let's try this with all 3 of them. We'll say this part right here. I'm just going to mark it blue. We'll say this is 2 marks, this is 2 marks, this is 2 marks. Those are all going to be the same length. I'm just going to make those 4. I'm just going to make up some numbers here. We'll say all those are 4. And let's see, I could probably use red on here. This is red. And there's these guys here. I'll use 3 marks. I think I'll just say these are 6 in length. They probably won't be 6, but we'll just say 6. Okay? How many triangles are formed? How many smaller triangles are formed here? Four of them. What are the lengths of all four of those triangles? If you look at the side lengths, doesn't each one of them have a 4? Does each one have a 5? And does each one have a 6? Look at this top one. Hey, here's 4, 5, and 6. This middle one here, here's 4, 5, and 6. This one right here is a 4, 5, and 6. The one on the left, 4, 5, and 6. So each one of the triangles then has a 4, 5, and 6. Okay? We can also do the same thing with the angles. What happens now is we now have 4 triangles. They're all exactly the same size. Okay? They're exactly the same shape. They have all the same dimensions. They'll have all the same properties. Okay? And I have 4 triangles this way. So the way we say this, the 3 mid-segments of a triangle, divide the triangle into 4 congruent triangles. Okay? It divides the one triangle into 4 congruent triangles. This is a little confusing. I'll be honest with you, this is a little weird. Unless things are color-coded or marked really nicely on here, it's tough for me to tell kind of exactly what's going on because the orientation gets kind of funny. So here's what we're going to do. It says triangle DEF, EG, this part right here, it's going to be equal to DG. Okay? What else is going to also be the same length as those two individually? JK, this one right here is also going to be the exact same length. Okay? And here's the idea here. Remember, this is the base of the triangle. This is now the mid-segment. The JK is now the mid-segment. So it's going to be half the entire length. Does that make sense? So this whole thing here, ED is, 10. Each one of these small parts are 5. And JK would also be 5 as well. Okay? Secondly, it says up here that EJ and FJ are each going to be the same length. So that'd be this guy here, and which other one? BK, right? So we'll mark that one as well. Lastly, I'll do this in blue. It says that BK and FK are the same length. So we'll mark that with 3. And that means that this one also right here is going to also be a length of 3. Okay? For me, it helps that they're in different colors. If you have like a highlighter or something colored pencils, or you can do it that way, that's fine. Otherwise, I think if you do mark these with 1 tick marks, 2 tick marks, and 3 tick marks, I think it'll work out and you can kind of tell what's going on. Okay? It says GJ, what's it going to be parallel to? Tell me the entire base of the big triangle. Yeah, BF, probably. I think you said it right the first time. BF, I just wasn't done. I wasn't ready to listen, I don't think. Okay, so basically, this guy right here is parallel to the bottom one, the entire bottom piece right here. Okay, next, JK, which was red, this part right here, what's it going to be parallel to? Yeah, ED, this entire piece right here, ED. And make sure that when you write line segments that you put a little line segment symbol on top. GK, this one in green, so this piece right here, and it's going to be parallel to this large side over here. How do we name that? EF. I'll put a little line segment over the top, line segment EF. Okay. Is everybody okay so far? Okay. Again, kind of a weird concept here. We know EJ, and that's green, is going to be congruent to what else? Well, it kind of tells us one of them right here. EJ is going to be congruent to what else? Well, FJ. And what else? GK. Okay? So all these green ones are going to be parallel. Okay? EG, this is what I did in blue, I think. Nope. Red, sorry. I got my colors right now. It says EG, which here's an EG, so that's these guys right here. We know it's definitely congruent to DG. And what else? JK, also the other red one that's on here. The mid-segment of these two pieces. Or the mid-segment is associated with it. DK, okay, that's in blue, right up here. DK is going to be congruent to FK for sure. And then which other piece? GJ. Let's kind of dissecting that triangle, and again, there are 4 congruent triangles. Here's 1, 2, 3, and 4. that are all four congruent. And there's lots of things we could do with congruent triangles. That we've kind of talked about before, but we'll see how it gets applied in this homework as well. Okay, let's talk about a mid-segment conjecture for trapezoids. Okay, mid-segments for trapezoids are just a little tiny bit different. It says the mid-segment of a trapezoid is blank to the bases. And I'm going to put parallel on here again. And again, the symbol for parallel looks like two slanted parallel lines. Parallel to the bases, and is equal to, this is kind of a weird way to write this, equal to the average of the two bases. Okay, so if we were to put this in here, again, this would be the midpoint. This would be a midpoint over here. So it looks like this. And we're going to call this MS for the mid-segment. The idea here is that the length of M, the mid-segment, is going to be equal to the average of these two lengths. So basically I'd say with however long TP is, which is kind of funny, and RA, those lengths, and we would just divide that by 2. Oh, I wrote that backwards, I'm sorry. That's not right. Sorry, it's the two bases, so it's TR, the top, plus PA, the bottom, divided by 2. Top plus the bottom divided by 2. That's going to equal however long your mid-segment is. For us, that'd be MN. Okay, so for instance, if this is 10, and this is, I don't know, 2, that doesn't make sense. Hold on, let me do it this way. So that's 20. Okay, if this is 10 up here, this is 20 here. How long's the middle? We add them up. 10 plus 20 is 30. 30 divided by 2, 15. Okay? Because all that we do is we say up here, so that's 10 plus 20 divided by 2. That's 30 divided by 2, which is 15. For instance, just as an example. All right. Other questions so far? All right. Sometimes these come out really nicely. Sometimes you have to round to the nearest tenth for some of these things. Tyler, can you help us with this one? First one, read it for us. Oh, Tyler Cox.
In the diagram, MN is the mid-segment of trapezoid PQRS defined.
Okay. So how do we find MN? 16 plus 9 divided by 2. What's 16 plus 9? Tyler Cox. 24 is incorrect. 25? What's 25 divided by 2? 12.5, and then we have to label it with the proper units, inches. If you don't label it with inches on your homework, you're not going to have it right. Okay. Tyler Mancuso, number 5. Sure. 30 plus 12? Divided by 2. What's 30 plus 12? 32. 32 divided by 2. What's, yeah, I was going to say, what's 4 divided by 2? What's 2 divided by 2? That should be 21. What units do we have? Feet. So 21 feet. Okay? Now here's the deal. Without looking at your homework, don't look at your homework yet. We're back over to where we're at. How could they make this different? How could they change this? What's one thing, Hannah?
They could make you find, they could put an X in there and make you find that.
Yeah, so say they say this is, 2x plus 9 or something like that. Okay? You're going to have to do that. You could say like 12 plus 2x plus 9 divided by 2, and you can kind of figure things out. Maybe that would happen. That kind of seems weird, but yeah, that could work. Okay? What do you think they could do, Nick?
If you give me the mid-segment and one base and make it find it.
Yeah, so that might look kind of weird. Let's try that. Okay, so on this problem, they say this is 12, that's a small one. What if they say this is 16? Okay, can we then label this as sort of like x here? How do we solve for that? What would that look like? Well, 16, the mid-segment equals 12 plus x divided by 2. And well, how do you get the x by itself? This whole side's divided by 2, so what do? Well, you multiply both sides by 2. That'll give you 32 equals 12 plus x. Subtract 12 off of both sides, and x will equal 20. So this base right here will turn out to be 20 feet long, which makes sense. Sort of a shortcut way of doing this that would be a nice way to check your answers if it doesn't show any work, which I do need you to show work, is you can say, well, hey, 12 plus what gives me 16? 12 plus what gives me 16? 4. So 16 plus 4 gives me 20. It's a good way to check your answers. It's a really easy way to do the problems. But on your homework, I do need you to show your work. You can't just be like, well, I just know what it is. Okay? You do need to show your work on your homework. Is there anything else they could do? They could put some variables in there. You have to solve for the variables. Technically, they could have you do something with these side lengths. I don't know if they will or not, but you could also have to do something with the side lengths. Okay. You guys have about 15 minutes to be working on your assignment here in class. I do hope that you guys do take advantage of that, and if you do have questions, make sure to let me know.